One of the problems we have as teachers is sometimes conveying to students how we know things that we can't see. Especially with younger students, they will say things like, well, nobody's ever seen atoms, so how do we know they exist? Of course, that's not true. That's sort of not true anymore with these new scanning electron microscopes where we actually can map the surface of solids. But I like this for either really middle school students, just the whole idea that even without seeing, you can determine things, or when I'm talking to my advanced placement students, for an analogy to explain how a scanning electron microscope might work. So all I'm going to use is a refrigerator magnet, and these are easy to come by. There's a lot of businesses that give them away, and you just want to make sure that when you're in the mall and you see someone giving these away, that you tell them you'd like a few extras for your friends, 20, 30. But usually they'll give them to you because they don't know that you just want to cut them up. And I explain to the students that, it's magnetic, and they can put two together and see, yes, they're magnetic, but we don't know how the magnet is arranged on there. So if you look over at this chart, there are some possible arrangements for the magnets on the refrigerator magnet. It might be one side's north, the other side's south. We might have stripes. Could be a checkerboard, or maybe half of it's north, the other half south. So what the student's going to do is determine what the arrangement is of the magnetic field on the refrigerator magnet. And all I did is, it doesn't really matter what size you use, but I'm picking a pretty good size here. And I've cut this larger magnet in half. And then I'm going to make a cut on one side and then the other side. And I've got two probes. One of the probes is going to work, one of them won't. Okay, so what I'm going to do is I'm going to run the probe across here. And can you hear already when I say it's going to work? And in this direction it goes up and down. In this direction it doesn't. The kids are just fascinated with it, if you don't mind having a whole classroom of kids running magnets back and forth like that. And it's something you want to let them do. But they easily identify B, the alternating north and south poles, as the arrangement on the refrigerator magnet. If you've got students that are beginning chemistry or middle school students, then you probably stop with that. And you explain that even though you can't see those fields, you have information that allows you to determine that has to be the arrangement that's possible. If you have more advanced students, then you explain that this is an analogy for the scanning electron microscope, with the magnet being the surface of the solid and this being our probe. And there's a little diagram over here if you want to focus on it of a setup. Okay, and you can see that as it runs across the surface, the atoms, their electron density is going to vary as you go from atom to atom. And so if you shoot a beam of electrons on the surface, the repulsive force will vary depending on the electron density. So we kind of map the surface of that solid using the repulsion between our probe and the metal surface. And that is those lovely pictures that you sometimes find in the textbooks of the surface of a solid where they say, look, we can see atoms now. Okay? So I like using analogies with the students because there's many things that we can't actually do in the classroom, and the analogies help them really remember very well what we're trying to talk about when it's abstract. Thank you.